Okay, this is spring block system. I'll remove the mass, lower mass M2. Then I want the new time period and new amplitude of oscillation. So what we are doing a problem where if some mass is removed or added to system, what happened to the time period of oscillations of the system? So what is my question? So if a mass is added or removed, so here I'm going to remove this one. So block M2 is suddenly removed. Then what is the amplitude of oscillation? Then what is the new time period? Okay, some are asking, sir, what actually you are asking. So let me put question. Find the amplitude and time period of oscillation on removal of block of mass M2 at mean. Okay, this one. So it is a test. So initially the system will have elongation. So what is the state of spring? Elongated or compressed? It's elongation. No? So write this is. So what is the equation? You can write it now. Who will balance this weight of these two blocks? Kx naught should be equal to, uh, shall we write m and 3m, or let it be, no problem. This will be m1 plus m2 into g. I'm going to remove the block m1. What will happen to the, on removal of block m2, what will happen to block m1? Will it be there only? So what is the state of this? Earlier, kx naught was balancing, m1 plus m2g. Now, when I remove this block m2, so how much of spring force will act? Spring force will not change suddenly. Will I agree, all of you? No, kx naught is equal to m1 plus m2g. Is it kx naught greater than m1g? Yes, it is. So it starts accelerating. It will start moving up. It will start moving up. So somewhere, so now as it starts moving up, so what will happen? The spring force will decrease. So the net force acting on it will be decreasing. Acceleration decreases. Somewhere it will come to mean position. Okay, I don't know mean position. Somewhere here I'm going to take it. There's a mean position. It's available in book where you don't have explanation. Diagrams are not there. They wrote some equations or something. Okay, the new this is k r naught. I'll write. What is r naught? The new mean position it is. It's a new mean position. Let it be here. Okay, I get this one. So what is this? This will be r naught. You call it. So this will have maximum velocity. And now what will happen to it? So as it starts moving, as it starts moving up, now m1g will become greater than k r naught. m1g will become greater than k r naught. Then it will undergo retardation somewhere here in between some position. Let me show it. So it will have velocity v1, retardation like this, say some kx1 m1g, and finally it will come to instantaneous rest. Okay, this will be instantaneous rest here. So this is like it will have some like still some elongation will be there in the spring. Let it be that one. Okay, now tell me what is the amplitude? This is the lower extreme. This is a mean. This is upper extreme. Will I agree? Okay, let me indicate those lower extremes. Okay, I think we have a practice of showing this one. Okay, now what is amplitude? The distance from upper extreme to mean, or the distance from mean to lower extreme. That should be called as amplitude, no? So this is what the amplitude. It's asking to calculate this value here. Okay, let's write kx naught. What is kx naught equal to? What is kr naught? What is amplitude? Looking at the diagram, x naught minus r naught. So what is x naught equal to? R naught plus a. What is x naught? M1 plus, what is R naught? M1G by K.
Sir.
Yeah.
Sir, how did you write, sir? X naught equals to R naught plus A. Okay, sir. Okay.
Huh? Some from
Okay,
diagram.
sir.
Huh? Yeah. Or else the difference of these two is what this amplitude. I think here I'm having you have to look at this part. What did they say? X naught plus the blue color line. I'll extend it so that it'll be easy for you. Agree? No. This is so this amplitude. So what is amplitude? No amplitude. What you should write? M2G by K. What mass you remove? No, the weight of that by spring constant will be the amplitude. It's very important at many applications it is there. Of course, we don't use that one, but at many places it will be there. So when some mass is removed, no, so what will be the new amplitude? The new amplitude will be M2G by K. It's a very dangerous, no, the spring block system. By some means, if mass decreases, it starts oscillating. It was supposed to be a test. Then if mass decreases, it will oscillate. Then what is the new time period? What was the earlier time period? Time period was, what was the earlier time period? So what is the new time period? New time period is only M1 by K because M2 is removed, no? Here block M2 is removed. Getting this one, very nice problems, huh? A student has to, I'll bet you search any book available here. Nobody will show this one. They'll write some explanation or write some equation, not there. So students development has to fight with equations. Why is writing this one? How is writing this one? Not possible, no, until we work out. So solutions that are available in book, what happen are just only a 10%. So don't think that you have a book